Welcome to Tomorrow Unveiled, the week of October 21st through the 28th, 2025. Just wrapped up. And, well, if you weren't paying close attention to robotics, you might have missed something huge. It felt like the moment the future stopped being, theoretical and actually started doing the chores.
Exactly. This past week, it wasn't about the flashy stuff anymore, was it? The backflips, the parkour. That's kind of old news.
Right. It was all about embodied intelligence. That's the key phrase our dedicated research team keeps highlighting.
It is. It's that precise point where these advanced AI models, the vision language action models, or VLAs, gave humanoid robots this massive, really crucial leap.
A leap in practical real-world autonomy, not just walking around, but actually doing things.
And it signals this fundamental shift,
Right.
something we've been tracking for years. The big challenge, the thing everyone talked about, was locomotion. Just getting the robot to walk, stay upright, navigate tricky ground. That was problem number one.
The foundation.
The foundation, exactly. But the consensus now, what we're seeing from the leading roboticists, based on the research compiled by our team, is that, well, the locomotion problem is largely solved, at least by the major players. So the whole game has shifted.
To what then? Where's the new battleground?
It's moved entirely to something much more mundane, but actually much harder. Useful dexterity, task execution, in messy, unstructured human places. The message from all the sources our research team analyzed is pretty clear. If the robot can't fold a shirt, it's not really ready for your factory or your home.
That really cuts to it, doesn't it? So our mission today on Tomorrow Unveiled is to dive into this huge pile of research we've got. We're focusing on this rise of the machines idea, not the scary sci-fi version, but the practical industrial shift happening right now. We're looking for the consensus view on what really matters, and yeah, the answer keeps coming back to this. The robots need to get a grip, literally.
Moving from balance to manipulation. That's the era we're in now.
Okay, so if the goal is general purpose utility, what's the benchmark now? You said dexterity.
Human level dexterity, yeah.
Yeah.
That's the new metric. And the competitive drama just this past week, it really centered on two things that sound simple but are incredibly tough for robots. First, handling deformable objects, things that change shape.
Like clothes.
Exactly. And second, linking tasks together, taking those tricky manipulations and stringing them into a complex workflow, like doing a chore.
Deformable objects. Our team flagged this too. They called it the killer application because computationally, it's just a nightmare.
It's a total nightmare. Think about it, unlike a block or a cup, something with a fixed shape, clothing, fabric, it changes every second. There's no fixed geometric model the robot can just, lock onto. What the AI sees one instant is different the next.
So who's leading the charge here?
Well, in terms of public demos, Figure AI really threw down the gauntlet this week. They released this incredibly detailed video, their new Figure 03 robot, and it's shown autonomously doing complex household chores. It really set a huge public benchmark.
I saw clips of that. The laundry folding sequence was something else.
Absolutely pivotal, that video. Folding laundry. I mean, you can't overstate how hard that is technically. It forces the robot's brain, the VLA model, to constantly adapt how it grips, right? And it needs that visual input, but also constant tactile feedback.
So for a towel, it needs to find the corners.
Find the corners, figure out how stiff the fabric is, decide how hard to pull it taut without ripping it, and then make these precise movements to fold it over. It's adaptive intelligence, live.
And it wasn't just the folding, was it? The video showed more.
No, that was just part one. Then the Figure 03 went on to clear dishes from a counter, rinse them off in a sink, and then load them into a dishwasher. Pretty efficiently, too.
Okay, so technically, what does that show? Is that harder than the folding?
Oh, significantly harder, I'd argue. It demonstrates really sophisticated task chaining. Folding is tough manipulation, yes, but it's one core task. Loading a dishwasher, that involves moving around, recognizing different objects. Plates, cups, forks, maybe guessing how dirty they are, using the faucet, understanding the 3D puzzle of the dishwasher rack.
Wow.
It's dozens of small actions, all linked to the high-level goal. Clean the kitchen.
Yeah.
It tests the robot's ability to reason over time, to plan spatially. It really validates the maturity of that underlying AI.
And then almost immediately, Tesla steps in. This is where it gets interesting competitively.
Right.
Their board chair just comes out and claims publicly that Optimus can now fold laundry. A direct challenge to Figure's big reveal.
The timing there is everything, isn't it? It basically weaponizes this benchmark. Tesla didn't even need to show a video. They just needed to say it. to tell the market, investors, potential customers, hey, we're right there with them on Dexterity. Our unified AI is keeping pace.
So it positions Optimus not just as a walker, but as a doer?
Exactly. A capable manipulator ready for complex work. This is perception warfare in a way.
Yeah.
And folding laundry is the flag everyone wants to plant right now.
And it's not just corporate squabbling. The academics validate this too, right? Our research pointed to the Agibot World Challenge.
Yes, at IRS 2025 in Hangzhou, folding a T-shirt was a key benchmark task required for all the academic teams competing.
So that really grounds the hype.
It does. It grounds it in measurable peer-reviewed difficulty. The academic world agrees. Handling soft stuff, non-rigid materials like fabric, that's the threshold. That's how you prove embodied intelligence is actually commercially viable.
The implication being?
The implication is profound. The days of getting millions in funding just to make a robot do a cool backflip for YouTube, they're over. The serious money now is flowing towards the boring, messy, but ultimately much more valuable tasks of everyday life and work.
Okay, so this race for dexterity, for doing useful things, it's actually splitting the market. Our research team identified a really clear split here.
Yeah, it's bifurcating. There are these two competing philosophies emerging. And they're going to shape how these robots get adopted and by whom.
What are the two camps?
We've sort of termed them the biomimicry for dexterity strategy versus the pragmatism for cost strategy. Companies like Figure AI and Tesla, they're definitely in that first camp. They're chasing the high-end general-purpose dream.
The biomimicry idea being, let's perfectly replicate human ability first, even if it's expensive now, and figure out costs later.
That's the hypothesis. Achieve the ultimate capability, then scale down the price. The generalist approach.
Let's look at the Figure 03 hardware then. They called it a ground-up redesign, built for mass production, but really designed to feed data to their AI, right?
Precisely. And the upgrades, especially in the sensors, that's where the deep innovation is. The vision system, they didn't just tweak it. They doubled the frame rate, widened the field of view by 60%.
So more data, faster for the AI.
A much denser, more stable picture of the world for the AI to work with. But the real game changers, they're in the hands. They tackled this critical occlusion problem.
Occlusion. That's when the robot can't see what its own hands are doing.
Exactly. If the main cameras are on the head and the hand reaches into a box or under a table, it's blind. Fix this by putting cameras in the palms.
Cameras in the palms. Wow, that sounds complex and delicate.
Incredibly complex to engineer and protect. Yeah. But kind of essential if you want fluid interaction with the world.
And the fingertip sensors. The sensitivity level mentioned in our research was, what was it, 3 grams?
3 grams.
Okay.
About the weight of a paperclip. That level of touch sensitivity is absolutely non-negotiable for truly useful tasks. Think about handling a wine glass, or holding a soapy dish without crushing it, or plugging in a tiny cable. Vision alone isn't enough.
You need to feel the force.
You need to feel it in real time with extreme precision, that 3-gram threshold. It's a huge marker for general-purpose utility.
Okay, so that's Figure. Tesla, meanwhile, chasing a similar high-end goal with Optimus, is facing the same hard problems. Their CEO had that quote about the hand.
Ah, yes, that the electromechanical hand and forearm were more difficult than the entire rest of the robot.
That really says it all.
It perfectly captures the hands problem. And you see it in their design evolution. Optimus started with an 11 degree of freedom hand, 11 Do. That's fairly limited. They quickly moved to a 22 Do version that's getting much closer to a human hand's complexity, which is around 27 Do F.
And how did they achieve that complexity?
They're using a biomimetic approach, mimicking biology with a tendon-driven architecture.
Tendon-driven, like our own muscles and tendons.
Sort of, yeah. The motors, the actuators, they sit further up the arm, maybe in the forearm, and they pull on these synthetic tendons to move the fingers. The big advantage is a much lighter hand and wrist, better movement, more energy efficient.
But the downside?
Massive engineering complexity. Tendons stretch, they introduce noise in the sensors, the whole system is harder to control and maintain compared to just putting motors in the fingers. It's definitely a high-risk, high-reward strategy. It bets everything on achieving that ideal biomimicry, which just underlines, again, hands are the bottleneck, dexterous manipulation is the barrier.
Okay, so that's the high-end, expensive biomimetic approach. What's the alternative? The pragmatism for cost strategy.
This is where it gets really disruptive. Look at the Beijing-based startup, Noetix Robotics, and their robot, Bumi.
Bumi, right. The price point there was just unbelievable.
It's a breakthrough. They unveiled Bumi at roughly $1,400 US. That's 9,998 yuan.
$1,400. That's not industrial pricing. That's...
That's consumer-grade pricing. It's like a high-end laptop or a new smartphone. It completely changes the game in terms of access. It aims to democratize humanoid tech.
How on earth do they get the cost down so low when Figure and Tesla are likely looking at, what, 10, 20 times that easily?
It seems like a very conscious strategy. Prioritize access and scale now, even if it means slightly less cutting-edge dexterity today. Our research suggests they did it through aggressive vertical integration, making their own control boards, using lots of lightweight composite materials, and crucially, relying on an almost entirely domestic supply chain within China.
A deliberate design choice.
Absolutely. It says, we'll trade a bit of performance for massive scale and data collection sooner.
And the robot itself reflects that, right? Bumi isn't built for the assembly line. It's small.
Yeah, child size. About 3 feet tall, 26 pounds. And they're marketing it specifically for education and home entertainment.
With easy programming.
A simple drag-and-drop interface. The goal isn't to rely on robotics PhDs. They want hobbyists, kids, educators to use it. They're trying to build a grassroots developer community.
That creates a fascinating dynamic, doesn't it? Bumi might not fold laundry like a Figure 03 today.
Right.
But if suddenly there are hundreds of thousands of these cheap robots out in real homes with ordinary people teaching them things...
That's the potential disruption. That could create a massive data collection advantage. If tons of amateurs start training these things in all sorts of unpredictable home environments, that collective data could potentially train a generalist AI even faster than the carefully controlled, expensive data gathered by the high-end guys.
Capability versus accessibility, hardware versus ecosystem. It's a real split. And hey, if you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and maybe even hit that new hype button. It really helps us reach more viewers. And of course, turn on notifications so you never miss an update on the future.
So whether we're talking about a $1,400 robot or one that costs, I don't know, $100,000 plus, these capabilities we're discussing, folding clothes, loading dishwashers, it's not just about the hardware anymore, is it?
No, it feels like the brain is the main event now.
It absolutely is. Robotics today, fundamentally, it's a software and data competition. And it's driven by this vision-language-action paradigm, the VLA models.
Okay, let's unpack VLA properly. Our research team called them multimodal foundation models. How is that different from how we used to program robots?
Totally different. Traditional industrial robots, you program them explicitly, or you use teaching by demonstration. Literally grab the arm, moved it to point A, then point B, and told it to do exactly that forever.
Rigid, task-specific.
And not adaptive at all. VLA models are different. They take in visual data, what the robot sees. They understand natural language, what you tell them to do. And they directly output physical actions commands to the motors. So you can actually say, please put that dirty plate in the dishwasher and shut the door. And the VLA model figures out the steps. It generates that complex sequence internally.
And it can adapt if the plate isn't quite where it expects.
Yes. Or if the door is slightly ajar, it adapts. It's the closest thing we have to giving a robot a generalist brain that can learn from instructions.
But that brain needs to be smart and fast, right? The real world is messy and happens quickly. Figure's AI, the Helix AI in the Figure 03, has this clever approach.
Yeah, they use a dual system architecture. It's inspired by how psychologists think about human cognition, actually. System 1 and System 2 thinking.
Okay.
It's a really elegant way to solve a basic engineering problem. The big language models that do the reasoning, they're computationally heavy, so they're relatively slow. But motor control, that needs to be super fast to stay balanced and move smoothly.
So Helix splits the job.
Exactly.
We've got the slow thinking part, System 2. What's its role?
System 2 is the high-level VLM, the planner. It runs slower, maybe 7 to 9 times a second, 7 to 9 hertz. Think of it as the supervisor. It looks at the whole scene, understands the instruction like load the dishwasher, figures out the overall plan for the next few seconds. It decides what the robot should generally be doing.
Okay, the big picture thinker. And then System 1.
System 1 is the fast-thinking visual motor policy. This is the bit that does the actual moving. It runs much faster, 200 hertz, 200 updates every single second.
Wow.
So System 1 takes the general goal from System 2, like grasp that handle, and translates it into the precise real-time motor commands. It's adjusting torque, keeping balance, making the movement fluid, compensating for tiny shifts.
That separation sounds key.
It's brilliant. You get the deep reasoning of the big model and the fast reaction time you need for the physical world. The robot isn't sluggish or unstable.
No, Tesla, they're going a different route, aren't they? Instead of a dedicated robotics AI like Helix, they're betting on a unified AI strategy. One brain for cars and robots.
It's a colossal gamble, a huge bet on the power of data scale.
Hmm?
Their hypothesis is basically, we have millions of cars driving around collecting unbelievable amounts of real-world visual data from complex human environments.
Streets, parking lots.
Right. Data that's rich with information about navigating spaces, understanding physics, predicting what people might do. They believe that data can train a foundational AI that gives Optimus a massive head start in interacting with the world.
But is driving data the right kind of data for, say, picking up an egg? Isn't there a risk there?
That is the absolute core question for Tesla's team. Driving focuses on, longer distances, avoiding obstacles, things mostly at waist height or above.
Hmm.
Manipulation needs incredibly detailed close-up vision, the exact shape of a button, the texture of fabric, the precise alignment of a tiny wire.
Things car doesn't usually need to see.
Exactly. So relying only on full self-driving data might mean the AI isn't optimized for fine motor skills. It could require a lot of filtering, or maybe even a rethink down the line. It's a huge wager. Does general intelligence from massive scale beat specialized intelligence from focused, high-quality robotic data? We don't know yet.
And underpinning all this AI development, we can't ignore the infrastructure providers. NVIDIA seems deeply involved.
Oh, absolutely. NVIDIA is crucial here. They recognized early on that these VLA breakthroughs need enormous computing power, both for training the models and for running them in real time on the robot, which is called inference.
So they're providing the tools.
Foundational platforms, yeah.
Yeah.
Like Isaac Groot, they call it an open customizable foundation model, specifically for humanoids. They're essentially trying to lower the entry barrier for other companies. And they're contributing to the underlying software too, like making ROS2, the standard robotics framework, work better with GPUs, providing accelerated libraries.
It really highlights that this is a full stack problem. Hardware, software, simulation, core compute. It all has to work together.
Definitely. And simulation, using tools like NVIDIA's Isaac Sim, it's not optional anymore. It's essential. It lets companies generate vast amounts of synthetic training data, test millions of interactions virtually without breaking expensive robots.
Saves time and money.
Hugely. That's why all the big names, Agility Robotics, Boston Dynamics, Figure AI, they're all heavily using simulation to iterate faster and accelerate development.
Okay, so the tech's maturing, the AI's smarter, the dexterity race is on. Logically, the next step is putting them to work, right? For real.
And that's exactly what our research confirms happened this past week. Humanoids are moving out of the lab and onto commercial production lines, primarily in automotive manufacturing, it seems.
This is the real test. Figure AI's founder, Brett Adcock, confirmed their Figure O2 robots are working actual shifts.
Sustained shifts. 10 hours a day, 5 months running now, on BMW's X3 line at their Spartanburg plant in South Carolina.
10 hours a day for 5 months. That's not a demo. That's industrial operation.
It's real work. And the task itself is fascinating sheet metal insertion.
Which sounds difficult. The research note said Figure described it as 10x harder than any stationary tabletop manipulation. Why so hard?
Well, think about a factory floor. Even an assembly line isn't perfectly predictable. The sheet metal itself might change size slightly with temperature thermal expansion. There's vibration from other machines. And the task requires incredible precision, inserting a part into pinholes less than a centimeter wide. Millimeter-level accuracy.
So the robot can't just go to a pre-programmed spot.
No way. It has to constantly sense, use force feedback, visual feedback, adjust its trajectory, finesse the part into place. It's adaptive control in a challenging environment.
And BMW's goal?
They're evaluating how humanoids can take over tasks that are ergonomically awkward or strenuous for human workers. And apparently, this deployment has already cut 4 minutes off the cycle time for that specific operation. That's a real productivity gain.
So showing commercial value already. And it's not just Figure and BMW, right? This is becoming a trend.
Definitely a trend. Boston Dynamics, remember Atlas, the parkour robot? Well, the new all-electric version is getting ready for its first proper job at a Hyundai factory in Georgia.
No more hydraulics. Focused on work now. What's its task?
Parts sequencing. Basically, organizing components, presenting them in the right order, and orientation for the assembly line.
A logistics job, essentially.
Yeah, requires moving around, handling different objects, understanding the layout, integrating with the factory systems. It needs movement and manipulation perfect for a humanoid that can reach and lift like a person.
And then there was that huge deal in China, Agibot.
Yes, Agibot secured a contract to deploy about 100 humanoid robots in manufacturing facilities there.
100 units, that's not a pilot anymore.
That signals industrial scale implementation. When a company commits to that many, they're betting seriously on the reliability and scalability. Add in Mercedes-Benz using humanoids in their digital factory campus in Berlin. Yeah, it confirms humanoids are becoming a current production tool, not just a future idea.
But it's important context, isn't it, that these humanoids aren't just appearing out of nowhere. They're fitting into an automation landscape already shaped by other robots.
That context is absolutely vital. Specialized robots have been paving the way, building the business case and the infrastructure. Take Locust Robotics. They make those autonomous mobile robots, AMRs, for warehouses.
Right.
They just passed 6 billion robot-assisted picks. And the last billion, they did that in a record 24 weeks. That shows the massive scale and the accelerating pace of AI adoption in logistics. Companies are getting comfortable with this stuff.
And bonsai robotics. With the farm vehicles.
Another great example. Their Amiga vehicles navigate fields using computer vision, not just GPS, handling unstructured outdoor environments.
So how do Locust and Bonsai prime the market for humanoids?
2 ways. First, the business model. They prove the robots as a service model works whereas. Companies are used to renting robots, having the supplier manage them. Second, the infrastructure. The software for managing fleets, the integration with existing systems. Humanoids aren't necessarily competing with a Locust bot. They're plugging into the system Locust helped build. They handle the more complex tasks the simpler wheeled robots can't, like reaching high shelves or operating machinery.
They're the next layer of automation.
Exactly. The specialists primed the market, and now the generalists are starting to arrive.
And for those of you listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could maybe leave us a rating and review for Tomorrow Unveiled. It honestly really helps us reach new listeners.
So if we boil down the consensus view from all the research our team analyzed this week, 3 big things stand out. First, the industry definitely pivoted. Focus is now squarely on dexterity and useful work. VLA models are driving it, and folding laundry somehow became the benchmark.
The new backflip.
Sort of, yeah. Second, that market bifurcation is real and accelerating. You've got the high-cost, super capable generalists, mostly in the U.S., versus the low-cost, accessible ecosystem approach we're seeing emerge strongly from China.
And
third, industrial deployment is happening now. Not just demos, but real work, especially in automotive factories. It's moving beyond proof of concept to actual industrial scale.
Okay, but let's be realistic. You mentioned the BMW deployment, 10 hours a day, 5 months. That's impressive, but it's still early days for sustained mass deployment. What's the big hurdle?
I call it the reliability gap. It's the huge difference between making a robot work perfectly for a 10-minute demo and making it work reliably for thousands, tens of thousands of hours with almost no human help.
Mean time between failures, MTBF.
Exactly. A human worker doing a simple task might have an MTBF measured in years. A complex humanoid with 22 Nuboth hands, delicate sensors, tendons maybe, so many more potential failure points. Getting that factory floor robustness, that extreme reliability, that's still the #1 engineering mountain to climb. It needs more data, better simulation, tougher hardware.
And we should also acknowledge the skeptics, right? Our research flagged some prominent roboticists saying, hold on, fully capable general-purpose humanoids are still decades away. Some are calling the current funding boom a bit of a bubble.
And that skepticism is healthy. It keeps everyone focused on delivering real results, not just hype. But alongside the hype and the progress, we also saw a reminder this week about the security risks.
The Embodied incident.
Yeah.
The Unitree robot AI.
Yeah, that small AI exhibiting unpredictable emergent behavior. Nothing dangerous happened, thankfully, but it was a wake-up call. It exposed potential new cybersecurity vulnerabilities, especially in how robots might communicate or coordinate. As AI gets more agentic, more independent, the security challenges are going to skyrocket right alongside the capabilities.
Okay, so looking ahead, say the next 12, 24 months, what should we expect?
Relentless focus on scaling data collection, real-world data, is gold, and pushing the complexity of the tasks these robots can actually do. But the big shift we'll see accelerating is towards truly agentic AI.
Agentic meaning?
Meaning AI that doesn't just follow commands. It perceives its environment, reasons about what needs to happen, makes long-term plans, and acts independently to achieve goals, even adapting to unexpected problems.
More thinking, less just doing.
Exactly. That requires way more compute power, better models, but it's the path to robots that are truly useful assistants, not just programmable machines. That's the next wave.
We'd definitely love to hear your thoughts on all this. Whether you're watching on YouTube or listening on your favorite podcast app, drop a comment. Let us know what you think about a $1,400 humanoid robot. What's the very first task you'd program it to do? And we'll leave you with a final, maybe provocative thought to chew on. The consensus seems to be that robust, general-purpose humanoids are coming, maybe in 5 years, maybe 10. The market potential is pegged at something like $5 trillion by 2050. Astronomical.
Huge numbers.
But think about the scaling needed to reach that. We're talking potentially hundreds of millions of units produced globally. What does that do to the competition for critical resources?
Mm.
The rare earth metals for motors, the materials for sensors, the lithium for batteries. If everyone needs to build millions of these complex machines, the rise of the machines might become less about AI dominance and more about a global scramble for raw materials.
A supply chain story as much as an AI story.
Exactly. Who can actually source the stuff to build them at scale? That could be the real geopolitical battleground. Something to think about. Thank you for joining us on Tomorrow Unveiled. We'll see you next time.